if you notice in the last few weeks, we focused on reinforcement learning. And I tried in the reinforcement, the reason I wanted to start with reinforcement learning, because it has a conceptual thing that it's extremely important to understand what is AI all about. In AI, we're making decisions. We want to find something out of the data and decide something. And reinforcement, the simple case we did last time, let me go back to it. Okay, if you go back to it, the one we played with last time, it's really based on like a game, and I'm trying to get from one place to another. And we elaborated on the decision of an agent studying the environment and acting on it. And based on the actions, it can move, or what is the reward is gaining, in making a decision plan on that. And then eventually you find out the value of every actions in every state, and based on that, eventually finding the shortest path. We will go over that several times more in the future. So if you didn't grasp that in the first time, don't be panicking. Okay, believe me, I went over it myself so many times until I became to be expert. Okay, but as we go along, I want to take a pause of it. Okay, I will come back, as I promised. I will come back to this example again and even spend more time on the algorithm itself. But now, from this example, going to this example, I know this one, before that, no, this one, okay? This one, we have like a card. This is like a real, by the way, a lot of places in automation. So this one, you're trying to keep the pole straight forward. And this one a little more complex. And how do we program it as a reinforcement learning? And it happened to be a little more complex, and we will utilize neural network. And the neural network will help us to replace the Q table we have developed here. If you remember, let me even open the code for you. If you remember when we did, okay, let me make it bigger. We talked about it, that we have an agent, we have an environment, and here we have a class of environment. That was the class of environment. Just to remind you, we have a class of agent, and the agents interact with the environment, and he's learning and develop and updating his Q table. Okay, I know that you cannot be really expert based on what I taught you so far, but we will get better and better. We'll come back to that. Now, this Q table idea, it's really the way reinforcement learning have started. As time went by and people started learning about neural network, they realized we can replace this Q table with neural network. So in this example, as we go later on, how do I move the car? Still don't push it too fast. You know, my objective eventually is to move it to the end, to the right or to the left. We'll see, we'll play with it as we go along. Let me just show you the result. We will learn about training like we did. And the learning was so fast, I combined them together. Here we will learn how to train that and then how to test it. If I click on this one, okay, it will show you the results of I pre-trained it. I'm not going to go to whole things. We will come back to that. We are not ready to really start this session. But you will see in a minute. Here we go. You see, it will start. This is eventually, I'm trying to push it to the end, but make sure that the post don't go or falls down. We'll get back to that. Okay, we'll come back to that. But before we get to that, I want to start the basic one, which is not the neural network. This is the foundation on which this what will be on top. This one will do another type of, again, this more sophisticated one. We'll come back and play with it. Then we'll take this one a little more complex. I will build it up later on. But this one is really my this is my favorite. I use it a lot in options trading, stocks trading. If you really want to make money, this is really the place you want to get eventually. This is beautiful stuff. We'll build up a very long way from there. We'll go into this one, we'll go to this one, then we'll go to this one, and then we'll come back to that. But let's start from this simple one. The way that I want to do, you know what, I'm going to, since this one is still, I'm spending time on for you guys, so it'll be easy. I will use my computer and I will demonstrate it from my own computer now. Just bear with me a second. All right, we're going to use this one, and let me give a little motivation, okay? And honestly, I used to teach statistics in the university long ago, and people spend the whole semester trying to answer the following questions. And then we'll see how beautiful neural network actually solve it without having to learn so much. Let me explain, okay? Let me click on this button first, and just to motivate the issue, and then we'll get to it. Okay, here's, you see a lot of dots. Everybody see the screen? Are you okay, guys? Can you see it? Yeah. Everybody can screen. Can you guys see it? All right, beautiful.
Yes.
You have a lot of dots here. If I click again, you'll give me another set of dots. Okay, I'm just asking him, give me 100 dots. This is the size, the sample size. I'm asking him, we'll go over the code, okay? We'll spend at least 2 sessions on this neural network so you can really grasp the idea and see how powerful it is. And as we go along, we'll get a little more sophisticated, okay? Here, the idea is I'm having a lot of that. By the way, let's make even simpler one. Make a 10 of them, only 10. Let me click this button, okay? And now it will make 10 dots. You see, you get 10 dots. And the question is, can you draw a straight line that will be as close as possible to all of those dots? If you take a statistic class, okay, you will see that people spend, here we go, I made some links for you. If you click on this one, you get a nice link to a whole topic of regression analysis. Regression analysis means, right, as close as possible to all the line, to all the dots. Let's make something similar to this one. Let's make a straight line, negative straight line, okay? Let's make a straight line. I'll make a negative one here. Let's make a negative here. So it should give me a straight line going down. It didn't like me. Let's make 100 here. Why it doesn't like me? I don't know why. Yeah, here we go. But it started from a very low. Let me make this one a little higher. Let's make that one 270. Yeah, here we go. By the way, you see, I can tell him to make me dots going down, going up. If you study a little linear line, a straight line, you have this is the A. The A is really what the line starts. You know what? I will make it so the line will be very close to it. The dots will be very close to each other. Okay. I asking the computer, generate dots that will be really kind of almost on one line. You see that? By the way, this point is really this 270. If I make it let's say 200, you will see it will start from a lower point. Okay, let's make it again. Okay, you see, this is the point they're telling him where to start the line. This is the slope. When it's negative, the line will go down. Okay, Fair enough? Now, if I give him sigma, it's really the standard deviation is how far away the dots from each other, how far they are really from that kind of a straight line. You can think about it, okay? If I make it 10, it will make them, the dots will still go down as we go, but they will be far away. We'll go and put it a little up to start from a little higher. Here we go. All right, here we go. So we're getting really dots that are far, they are not really nicely on straight line. And we're trying to make a line, to find the line that will be as close as to those points. If you go and read this one, the link I gave you, you can really learn about how statisticians solve this problem. Okay, by the way, here we go. Y equal to alpha plus beta x, when alpha is the point where the line is starting and beta is the slope. Okay, for different x's, you'll have different y's. So for every point here, you know, you have the x and you have the y. So for every dot, for a specific x, you'll get y. If you have a straight line, you know, when you have a straight line, it would be exactly on the line. Let's make it as close as, you know what, I will make it even smaller here. Let's make it 0.1. So it'll be really almost a straight line. You know, there's no, okay? So all those dots are really almost on the same line. You can tell, because I put it really small, it almost doesn't move the line. This is really a straight line when we have this kind of an equation. Okay, the line, the y goes straight line with the x based on this equation. Then later on, what we're doing here is really, we're trying to say, it's already going exactly, I'm putting some, statistician likes to call it noise, or machine learning people calling it noise, okay? They're putting noise into it, okay? So you can say, okay, what does it mean noise? So the y is not exactly going based on that. It has some randomization here, okay? And we'll see in a minute the code in Python, how does it do it? So you can be exposed how you can make something like that when you start learning, okay? So this is really generating. So I'm going to make a little noise by, instead of, this is like almost don't put any noise. But if I put a noise of 5, okay, it's a little noisy, so the dots will not be really on the line exactly. They'll be above or below a little bit than a straight line. So when I'm clicking here, you see it's not exactly like these dots, as you see here, it's above the straight line. This one, on the other hand, below probably. And our objective is, can we find, make it even more noisy. Let's make it 30, just to get the idea. Bingo. All right, see, this is really noisy. Now, generally, as the x going up, also the dot going down because the slope is negative. But now, not really. I mean, this dot is definitely above the line, and this one is definitely below the line. And statisticians try to find a method. How can I, based on those dots, I don't really know, let's assume I don't really know the a and the minus 0.7. Can I draw a line here to be as close as possible to those dots? That's what statisticians try for decades. Eventually, they found a nice way. And let me just go quickly. I'm not going to teach you regression analysis, okay? But I really strongly recommend you guys read this one, especially if you don't have a background in that. And this becomes to be, you will see as we go along and we solve this equation in machine learning and AI, we will see that we will solve much more sophisticated than this simple. And believe me, it took almost a whole semester to teach this course. And it was very hard for a lot of students. And you will see people study that one, they try to estimate the noise. Noise, it means if I have only dots, on every dot, how far it is from the straight line. I'm not going to go over all of those. You can go over that. I really strongly recommend, if you not, if you know derivative a little bit, you find those equations, how statisticians actually solved it. And then if you know a little matrices, you can solve it with matrices, solutions, and then eventually you have an estimator. This is like what they estimate to be a beta, the slope based on the point, and then what is the estimations of A? You will see there's probably down here somewhere. Here we go. That's the estimator for this, the point, the line going to start, okay? And that's the way statistician, and they try to understand how variance it is, how close, how good is my estimator, we call it. And you can tell by this mathematics, people get lost, honestly. And it's really not that hard when you really learn it. And here, just to get the idea, you have a, sometimes based on different sample, you'll give you different answers. And how much that will be changing or what is the standard deviation of those estimators becomes to be a big topic when you study statistics, okay? And then you can try to see if this one is really significantly different from zero, different from any number, and people spend a hell of a lot of time. Thank God, you should really say, thank God, you really don't have to study. This study depends on a lot of assumptions, and you can't really say much unless assuming that all those samples coming from normal distribution. And what do you do if it is not a normal distribution? You really don't know. You have no answer. And all of those stuff, you can forget about it. And that's the beauty of AI. We will learn how to use AI to estimate, okay, those two parameters. We'll see here, I'm not estimating, I'm just spending them. And by the way, every time I click here, I'll get a different sample. But they are all from the same structure. It has starting point and a slope, but I can have a different sample. You'll see the dots will start changing every time I will do it, okay? Let me refresh and run it again. And I will, let me keep, you know what? Let's keep this example with a slope. No, you know what? Let's do this one first, and then we'll change to a slope going down. Doesn't really make a difference. Okay, the same algorithm solve both of them. Every time I click on that one, I will get different dots. You pay attention here, I have a dot here on the top. If I do it again, it will not, I'm just making sure it will delete it first. Does it delete it? Or it doesn't when you get it again? No, it doesn't. I don't know why. It should. Let me refresh it. You'll see we'll get the different dots there. Why does it give me? It shouldn't give me the same ones. Push again. And do it again. Yes. And you get another sample. Now, okay. So every time we click, we get, if we want a bigger sample, we can ask him, give me 1,000 points like that. And I click on it. Let's see, we'll get many more dots. Okay. If I go again, I will make it, I don't know, let's make it 5,000 dots. He'll give me as many dots. This is called sampling. I'm sampling from the environment. Okay. Let's say a population, you can look, I'll give you one intuitions of what kind of a research people might do. Can I say is there a link between my weight and my height? Is there a link? People that are taller, usually they weigh more, okay? So I can say maybe the X will be my weight and the Y will be my height. Is there a link between? Usually it is like that, but not every person is exactly. So some people that are heavier, they might be short, okay? It's already 1-to-1 for all the people, okay? So that's why if I take 10 people, Okay, if I take 10 people, that might be the link, for this person is really skinny and he's not very high. This person, on the other hand, is a little heavier and he's also taller. But it's not going really as a straight line. The link between the weight and the height is already 1-to-1, okay? And we'll see more examples as we go along. But we're trying to learn from those dots. Can I learn something? What is on average kind of showing me this kind of a straight line? Now, if I have only 10 people, my estimate or finding that straight line will not be that good. But if I have a lot of people, let's say 1,000 people, it will be a little easier. Okay, I can tell why. It's most likely will go something here, will be a nicer. So the more sample, the more people I have, I can learn the relationship between the weight and the height better. I hope that's clear. Everybody happy? That's what people struggle a lot. And this kind of statistic doesn't have to be normal distribution. I won't go and teach you that. But statisticians are very limited to only places the distribution is normal distribution. The beauty about AI that it doesn't have. Let me show you an example. I'm going to do the same things. I'll just put a lot of epochs. I will explain what epochs mean in a second. Okay? It will take a little time. I will run it without even explaining to you how the AI is doing it. Okay? But you don't have to study the statistics. It's beautiful. And beautifully, it will find it's very close to the real one. I'm going to click here. It's going to run. And by the way, we will learn it. Okay, this is my, which one is it? No, this one. This one. Okay, it's running, as you can tell. It's going to run 1,500 times. He's teaching himself from the point to find the slope and to find where the line is supposed to start. You see, it's already 600. We will learn about those little numbers jumping a lot. They're always going down. We'll learn them. We even maybe make a chart of it. It's a very nice. You will see they're always going down. The more I learn, over and over and over, my error goes down up to a certain point. I don't really have to. You can tell here it's really kind of converging. The error is about 400, and it doesn't go much down. And that's a step that usually we will stop teaching it. And it's good enough. You will see that this one would be good enough to, here we go, it finished. And we got the results. And here we go. Look at that. It's so beautiful. Okay, look at the beautiful. This AI was able to tell me, you know what? It's probably 25.53. Even in the statistical method, you will never get the 25. It will be around the 25. And the slope was very close, 0.71, amazingly close. And the beauty, you will see when we study this algorithm, you will see we don't have to study statistics. We don't have to do what we did, okay? And the truth of the matter, to build up the algorithm, and that algorithm come in Python, as part of Python, you don't have to really go and study how it's built inside. We'll talk about it as we go along, but the beauty, it really gave me a straight line, okay? Let's do the same things this time. Let's make it a negative, okay, guys? And let's start here with 270. Let's see how that goes. Okay, let's make that one sample. Get a sample of, that will be a slope. Let's see if we can get a slope negative. Honestly, I didn't even try it. It's the first time I'm trying. Let's trend it again. Yes. Let's say, the beauty here, it doesn't know this equation. It only knows the dots. Can he make me a straight line going down? Let's see. So he's running. He's going to run 1,500 times. You see, he's running. The arrow is very big, as you can tell, but the arrow is going down. I don't know if you can see the numbers. It's 18,000, something like that. It's pretty high, but it has a long way to go, up to 1,500 times. As it does it, is improving and improving. Let's see how much it will go down to. Okay, so it's still going and doing. Let's wait for it a couple minutes or even less. $1,500. That's pretty high, by the way. We'll see if we can improve it. Right below 1,400, but still, in my opinion, high. We'll see. Probably will not do excellent job, but it's pretty high, the loss function. But let's see. He screwed it up. Totally screwed it up. Okay, you get me 45 and the slope 0.44. The slope is lower than it was before, but it didn't do a good job. We'll find, as we go along, we'll find out why did it do it, and it couldn't do it that way. Okay, and we will solve it. Okay, don't worry about it. We will solve it. Is increasing the size will be better? Let's try it. 3,000. Let's increase the size. Okay, will it do it better? Let's see. Let's refresh first of all. Let's do it again. 270. And where will it go? I will really try to figure it out. I didn't really try it before. So maybe I'm just, let's make 1,500 again. And make a sample size. Let's make 3,000. It will take a little time. Let's do a sample. Yes, okay. And let's estimate it. I can tell by the error that it's not that low, it's very high. I can tell it's not doing very well. And we'll figure out why, okay, as we go along. It seems to me very high, and we will get to that, okay? It's not doing very well, and we will figure out why it doesn't do it well. Okay, guys? Let me give it a chance to run, and we come back. Let's try to understand how the algorithm works. I will, first of all, how is this equation? Does anyone have a knowledge in Python? Anyone? Are there Python people here? Any Python guy? You guys don't know Python? Anyone? Wow. Can't hear anybody. Can you guys hear me?
Hello. I have some knowledge of Python.
Yeah. Strongly recommend you guys accumulate that knowledge, just because all the programming you do, you will do it in Python. Most likely people using only Python those days, mostly Python. Some people still using R just because they're lazy to study Python. But Python became to be one of the most important language. And in this course, I'm going to use only Python, although I know many languages. And the screens that you see painting, those buttons and everything, we use JavaScript. I frankly recommend to all of you, try to study those two languages, Python, JavaScript. And if you're really motivated and you really want to get a professional and you really want to be useful, you go and study a little Django, which combine those two together, utilizing databases, you will do very well, okay? But let me just talk about this function first, that activating to make those dots. How do you make dots like this one, okay? Oh, it's still running. Yeah, but this is doing much better, by the way. It's still cooking. It's still pretty high. I would expect it to be much better. But as we go along, we'll find out what's stopping it, and we'll learn. This is really one of the topics. How will you improve your estimator? You know, if you can tell the loss function was much higher before, it's going to be much lower. and we'll explore it as we go along, okay? Let me go into here. It won't let me now. Let him finish, and then we will, it's almost done. You know, the error is lower than it was before. Still, I'm expecting it to be less than 100. So it's still high, and it probably didn't do that great a job. Yeah, you see the A is 133, still positive, which is not bad. And it's giving me at least it's negative, which is really much better than it was before. And we'll fix it. Okay, it was better than it was before. But I rather to leave that one. We will solve this negative slope. Let's take an example of a sample. And how do I make those dots? Okay, let's learn a function. Okay, let me just strongly recommend you study Python, guys. It's such a beautiful language, very useful almost everywhere you will go. Let me just close some of those ones. It doesn't like me here for some reason. Okay. Let me close those. Why it doesn't like me? I think it has to do with
The Zoom stuff. Yeah. Could be
it
the
has to
Zoom.
do with the Zoom, I think. Doesn't it?
Yeah, I think you have to move it. You are muted, doctor. We have muted.
I made here a library. By the way, the beauty about Python, you start organizing all your code very nicely. We have a project, and we have all those libraries and a lot of projects. For example, now we're playing with these projects of neural network, okay, which give you this. And here you can tell I have a function called train, okay? And this train, I'm telling him if just to give me, you can see here from JavaScript, I'm sending a message to Python and telling him, just give me the data, okay? So this Python function is smart enough to get my instructions and give me only data. And you can tell we have a function here called generate data. I tell you what I will do, since not many of you knows Python, just expose you a little bit to a made of classes. It's quite complicated. You know, this one is a very advanced topic on Python. You can make a class based on several classes, like this one, this one, this one. And based on that, you can make functions inside. And that function can be internal functions. And it just, for the fun of it, how to do it. I tell you what I will do. Tell you what I will do. I will just, let me just spend some time on this one a little bit so you can see what does it do. And I will print those ones here. Let's do print. Okay, at least you learn this one. I'll tell you what I will do. I will do it this way. This is called dictionary. We don't really need all of those. I'll just take the whole things from here. Just you can really learn a little bit. I will take this one as well. And we'll just, let's take those ones as well. We don't need those. Frankly, if you're smart and you really want to get into this field, I strongly recommend to, yeah, we're missing here one. Okay. This is called a dictionary, by the way, with a tile, bracket, and this function generates the numbers. Now, every dot have an X and has a Y. And the way I get it is by calling this function called generate data, okay? So I'm generating data, and I will play with it a little bit, okay, with you? Let's play with it a little bit. So I will, just for the fun of it, I will define a underscore here to be 100 so you can understand what does it do. Maybe I will have it painted. You know what? I will have it painted. Yeah, you know what? I will paint it here. I'll show you the data here, and here I will make the picture. So we'll see both of them, okay, guys? So you can really learn it better and ignore those ones. We don't really care. And so let's see what we're trying to do here. If A is a minus 100, I will take, and let's leave the sigma there, B to be, let's do the B equal to 1. Okay, so it will be a straight line. You know what? Let's start with this one equal to 0. It will start from the bottom place. Okay, those dots. Okay, so you can learn a little bit how that one does. Okay, so we're getting the A, we're getting the B. This function generates those data. This is the number of pieces. We'll get it from the screen. I just play with those two. Let's see if the sigma is well. Let's try it, okay? Control C. I'm kind of cheating here, but at least you can learn from me. So now when I click here, okay, this one goes to this Python stuff. Here we go. It's really starting from the place here. You know what? Let's make sigma to be 0.1 so you can really see it. Let's click it again. Yes. And a second, it will be like a straight line. You see that? You already start from the point here and has a slope of 1. By the way, this is a box of 300 by 300. So let's see what really has been done. So beautiful. Okay. You know what? Let me do it again so you can see the whole. Let me just, so you don't get confused between, I clicked it twice. I'll click it again and see what happened. I'm telling Python, make, and here we go. So the Python is really generating that. And how does it do it? Okay, I'm telling him, you know, I want you to make a line for me, generate data that would be like on a straight line. Why? Because I'm telling him B to be 1, A is 0, and you know what? Just to convince you, you know, I'm taking sigma to be 0, 1, okay? So there's a sigma that's coming from here. It's really like almost telling him straight line. How does it do it? And this is this function. This is called a function in Python, okay? I'm making a function inside the function, which is beautiful. So this one is doing that, those dots. Is taking, now I'm telling him how many I want him to make. So I'm telling him, make me 1,500, but the truth of the matter, if you can tell, I'm overriding it by giving him, yeah, it's a little, you know, this number, you know what, I will tell you what I will do. So you'll be convinced that I'm doing everything from here. Let's make 10 points. Okay, let's take the sigma out also here. I will ignore the screen. I will paint it only on the screen. And let's do sigma 0.1. That's good enough. Okay, so I'm making only 10 points. I'm making a slope of 1, start from the origin, and no variance, like almost no variance. Okay, let me control C. And do it again. And you will see we'll get very similar, just 10 points. Because I'm ignoring those ones here, okay? No, but yeah, here we go. We got 10 points. You see that? They're almost on the same straight line. And what I'm telling him, give me only 10 points. And how does it work? I'm giving him all those parameters to this function. So this function, okay, let's look at it. This function, take all those, by the way, this is the default, but when I'm giving him a number like 10, it will ignore those ones. He's ignoring those ones. He's only using the one that I'm giving him. That's why I'm giving him all those values. So he's going to ignore all of those. He doesn't care about the stuff. This is like putting default. If I don't give him anything, he's going to use those ones. But since I'm specifying here the values, he's going to use those ones. So he's making those points with this one. So what does it do? This is, Python has all the distribution, has all ways of making random numbers. Like NumPy is a library of Python. You can make random number. And if you know what a uniform distribution, it makes like, it's picking numbers. It's going to pick 10 numbers out of between 0 to 1. You can see here 0 to 1, low and high, 0 to 1. It's going to pick 10 numbers between 0 to 1. After it takes that, is multiplying it by 300. What does it mean? X becomes to be 10 point from 0 to 300, because he's going to pick up numbers between 0 to 1 and multiply it by 300. So if he's picking 1 times 300 will be 300. Everybody got it? So just so you can really see it, I will do it here. I will print it for you. Print X, so you can see what X is. Okay, X will be all those numbers. Okay, I will print it for you. So you can see it in a minute. I will do it again. Then what it does, is putting it like trying to make a straight line, as I explained before, and adding some noise from normal distribution. Okay, and it gets sigma. And the truth of the matter, I'm almost not putting any noise. If I will take this one away, by the way, in Python, I'm putting no noise. It's ignoring now. It will be a straight line. Okay, I will print that one as well. And in fact, if you will check it, you will see that those lines, those points are all on the same straight line. Fair enough. I will print them. Okay, I will print it again here. Okay, so he's really getting all those points. That's really what we're getting here, the X and the Y. So this function, first of all, is picking up the numbers that I'm telling him. If I'm giving him a 10, it will pick 10. If I give him 100, it will pick up 100. And then he's taking numbers between 0 to 300. And taking those 0 to 300 for every number is finding the appropriate Y according to this line in this equation. Okay, and then he give me another 10 numbers for Y. And then he's returning it to me. So this is like a function that generates X and Y, 10 of them, so I can make a straight line. Okay, let's run it again. And now we can see the printout as well. Okay, I'm going to click again. And we'll go over the code again. But I really strongly, if you're serious and you really want to study AI, you should really go and study a little bit Python. Here we go. We're getting X. The X, there are 10 numbers here. Those numbers are between 0 and 300, okay? Okay, there's more than 200, there's less than 100. There are 10. Why there are 10? Because I told him, give me only, oh, there's 100 of them? No, no, I gave him here 10. Here we go. I told him, give me 10 numbers. So he is giving me 10 X's and 10 Y's. Fair enough? Yeah, I think I made a mistake here. How come? No, it's okay. Hey, very good. I thought I had a mistake, but I really don't have a mistake. Why I'm not having a mistake? Anybody can tell the X and the Y are the same. It's very clear it will be the same because the A is 0 and the B is 1. It's a straight line, which is 45 degrees here. Every Y is equal to X. So all the X's are the same as all the Y's are the same as the X's. So we don't have any error. Okay. So this is beautiful. I'm getting those numbers and sending them back to the JavaScript getting it and making the painting here. Let's make it a little more interesting. Okay. Let's make it now. I want more than 10 points. How would I do it? I just change it. Let's make it 20 points. You'll get 20 points now. Okay? You will see. You know, you learn how to make a function, it becomes to be so powerful. We'll get 20 points. You will see some similar, but we'll have more points here going on. You're seeing, here we go. We have much more points now. If we go into here, you see we have 20 points now that he gave me. They're all equal, the Y equal, all of them the same. Let's change the slope. Okay, instead of 1, let's make a slope of 0.5. You know, we'll have some slope, but not the same. The Y will not be equal to the X now, okay? If I run it, you'll see the X and the Y will not be the same now. Now, of course, this is annoying to work this way. Okay, it's very annoying to work this way. Here we go, you see, it has a slope, but it's lower than 1. 1 would be a straight line, 45 degrees. When you have 0.7, the slope is, if I want this line to be higher, I will change the A. If I change the A not to be 0, let's make the A to be 50. Okay, and then you will see it will be a straight line, but you will start from a different point. You will start from 50, like from here, something like that. Try it again. Yes, and bingo. Now you see it's annoying to go always to the Python and back. You see, here I go. You start, this should be around 50. Okay, I'm getting a straight line. Okay, this is really like, I have a function that makes that, but this is annoying. You know, I don't really need to do it this way. A better way to do it is just take all of those stuff from here. By the way, let me just remove the whole things I done. I don't want to change all of them. I don't really need all of those, but I really strongly recommend you guys learn how to use it. Yeah, we don't need all of those. Yeah, I don't want all of those. It would be much nicer to do it in JavaScript and just see the data. Okay, here we go. I'm removing all those stuff that we just did. And let's see now. I don't really want to see all of those. It doesn't really help me. It would be nice to get something like this. Let's make this one 50 now. And make that one 20 will be the same things. 20 and make this a small. When I click on this now, it will give me very similar. Very similar. I just put the same parameters. So it's going to give me very similar. You see, the slope here, how much I did before, 0.5. If I make 0.4 even, it will be even lower. So I will run it. Yes, bingo. And see how fast it does, and it's nice. If I'll make it 0.2 or 0.1, it will be almost a flat line. Okay, and that's the way usually you want to work. You want to work from the screen. You send the data to Python. Python does all the calculation and give you the results back. And that's really the way you would like to work. Okay, so this is like making the straight line. Let's make our example. Let's make here 0.7. And let's make this one. By the way, if I refresh it again, or if I click here, put all those numbers that I had originally. Okay, now you'll make me 100 points. The slope will be 0.7, 25 would be around here, but the sigma is high. So you want to give me a straight line, I'll put 0.1, you get a straight line like this one. Okay, and if I will change it to be higher, it will make more noise. It will put more noise. This is what in this equation, this is what makes the noise more noisy. Text parameters will make the dots not to be nicely on the straight line. So when I click here now, it will make the dots, but they are not exactly on the line. I hope that gave me a little bit motivation to start studying Python, start studying JavaScript so you can manipulate it. Next time, okay, we will talk about this trend. We'll talk about neural network and how neural network try to solve it. And we'll see next time. Okay, guys? Anyone has questions, please do. Feel free. You know? Anybody?
Any question, guys?
Yeah, go ahead.
No question from me. Thank you so much, sir.
Yeah. Anybody really interested studying Python? I know there's courses that SEO and Opio are teaching. Honestly, they are very inexpensive and you can pay installment, I know. But I really strongly, if you really want, you know, Opio and SEO didn't know anything 3-4 years ago. They are expert on Django, they are expert on JavaScript, on Python, and they're really maintaining all those websites that you guys exposed to. I very much advise you to do that, okay? It will, you know, you won't be able to do anything, you know, even if you understand machine learning, you won't be able to do anything, so it will be a shame, okay? Even this simple example, just knowing how to do this simple example in Python and JavaScript, you already will be in a very nice level, okay? And then we'll go through teaching you how to make buttons, how to make websites,